In today's video, we are going to be talking about hybridization in carbon. Hybridization, hybridization in carbon. Yeah. So when we talk about hybridization, all we mean is just mixing. Anytime you hear the word hybridization, the first thing that should come to your mind is just mixing. How we mix two orbitals to give one orbital. Maybe we make so hybridization mixing of two atomic orbitals to give an hybrid orbital. So the product of the orbital is an hybrid orbital. Product of mixing two atomic orbitals is an hybrid orbital. So the next thing you need to know is there are three types of hybridization that occur in carbon: the SP3 hybridization, the SP2 hybridization, and the SP hybridization. So at the end of this video, I'm going to be giving you a bonus tip on how to know when the compound is the carbon in the compound is actually SP3, SP2, or SP. I'm going to be giving the bonus tip at the end of this video, so make sure you watch till the end. So the next thing you need to know is the electronic configuration of carbon and how it contributes to bonding. So you know that carbon has an atomic number. Carbon has an atomic number of 6, right? Carbon has an atomic number of 6. So to write the electronic configuration, it's going to be 1s2, 2s2, 2p2. But you know this 2p2, the this p orbital is supposed to have 6 electrons in it, right? But it's just 2 that is there. So how do we write it? Using Ohm's rule, as 1 electron be here, 1 electron be here. Since it's just 2 electron that is in the p orbital, this 2 here represents the amount of electron in the orbital. This 2 here. So this is the electronic configuration of carbon when it's in the ground state, and it can be rewritten like as this: 1s2, 2s2. It can be written as 2px1, 2py1, as this is px and this is py. So it can be written as this in the ground state. So you can just say pz 2pz raised to power 0, because there's no electron in that part of the orbital. So this is pz. So this is the electronic configuration of carbon in the ground state. But in the excited state, or the state when it is about to bond with another atom, we rewrite it as this. So when it is about to bond, one electron from the 2s orbital will graduate from the s orbital to this empty p orbital. So it will be written as this: 1s2, 2s1, because one electron has gone away from this s orbital. So it will be 2s1, then 2px1, 2py1, and 2pz1, not 0, because one of the electron from this part has graduated from the s orbital to the p orbital. So it will be 1s2, 2s1, 2px1, 2py1, 2pz1. So this is the electronic configuration of carbon in the excited state. So this is the electronic configuration of carbon in the excited state when it is about to bond. Yes, and this is the major reason carbon has a valency of 4. You can see the unpaired electrons. This one is unpaired because you can see just 1. That means it is unpaired. If it had been 2, let's say it was 2, it is paired, because pair means 2, but you can see it's just 1, so it is unpaired. This one is unpaired, this one is unpaired, this one is unpaired. That's 1, 2, 3, 4. That's 4 unpaired electrons. So this is the reason carbon has a valency of 4, because valency means valence electrons, and valence electrons means unpaired electrons. So 1, 2, 3, 4 unpaired electrons, that is valency of 4. So you should also know that carbon has a valency of 4 because it has 4 unpaired electrons. So you should also note that. So let's talk about the SP3 hybridization. The SP3 the SP3 hybridization. The SP3 hybridization. So the first thing you should know is the SP3 hybridization is just the mixing of one s orbital. Notice this is SP3. That means one s and three p's. Is the mixing of one s orbital plus three p orbitals. This 3 means there are 3 p orbitals. There are p orbitals that are 3 in number. So it is the mixing of one s orbital plus 3 p orbitals. You understand? To give SP3 hybridization. And this SP3 hybridization, it is present in alkanes. So you should also note that SP3 hybridization is present in alkanes. SP3 hybridization is present in alkanes. It's present in alkanes. And you should also know the shape of the SP3 hybridization. The SP3 hybridization, they are tetrahedral. So that's the shape of SP3 hybridization. They are tetrahedral. And the bond angle is something you should also know. The bond angle is 109.5 degree. That's the bond angle of SP3 hybridization. So when we have a compound like methane or ethane or propane or butane, all those alkane compounds, those alkane hydrocarbons, you should know that they are SP3 hybridization. So if they ask you what's the hybridization of carbon in methane, or let's say in dodecane, you should know the hybridization is SP3. This is SP3 hybridized. So that's that on that. Yeah, so let's talk about the SP2 hybridization. SP2 hybridization. There are also things you should note under this SP2 hybridization. The SP2 hybridization, you should know that it's just a mixture of one s orbital plus 2p orbital. You should know that when I mean one s orbital and 2p orbital, I don't mean like 1s plus 2p. It means just one s, like one s number, and p orbitals that are 2 in number. One s orbital that is 1 in number, and p orbital that is 2 in number. So it is actually one 2s orbital plus 2p orbitals. You understand? So it's just 1s plus 2p orbital. I hope you understand this. So that's that on that. So it's a mixture of 1s orbital plus 2p orbital to give an hybrid orbital of sp2 hybridization. You should also know the bond angle of sp2 hybridization. It is 120 degree. That's the bond angle of sp2 hybridization, 120 degree. And the shape is trigonal planar. So when carbon that is sp2 hybridized, when it bonds with other atoms, it forms a compound that is trigonal planar in shape. And this hybridization occurs in alkenes. It occurs in alkenes. That's the double bonded hydrocarbons. So when we talk about ethene, propene, butene, benzene, all those alkenes, the alkene hydrocarbons, yes, they are sp2 hybridized. The carbon there is sp2 hybridized. sp2 hybridization. So let's briefly talk about SP hybridization also. So what you should note about SP hybridization. So SP hybridization, as you can see, 1s and 1p, 1s and 1p. It's not like SP3 is 1s and 3p, SP3, SP2 1s and 2p. SP is just 1s and 1p. So it is a mixture of 1s and 1p orbital. 1p orbital. Sorry, this is 120 degree. Yeah. So you should know the bond angle, the shape, and the hydrocarbons in which it exists. So the bond angle for SP hybridization is simply 180 degree. 180 degree. From the angle, you should know the shape. Since it's 180 degree, that's angle in a straight line. That means the shape is actually straight, which means it is a plane shape. That's linear. So the shape is linear. The shape of this kind of hybridization is linear. It's linear in shape and occurs in alkynes. It occurs in alkynes. That's a triple bond hydrocarbon. It occurs in alkynes. A triple bond hydrocarbon. The hydrocarbons are that the carbon has triple bond between them. So talking about alkynes, when we talk about ethyne, propyne, butane, those kind of hydrocarbons, the carbon in them are SP hybridized. So you should also know that. The bond angle. So the summary of this is you should know SP, the bond angle, the shape, the hydrocarbon exists. For SP, you should know that. For SP2, you should know that. For SP3, you should also know that. So those are the summary of it all. So I said I will drop a bonus tip in a compound, how to know if the central atom, to know the hybridization of the central atom very fast. So let's say you are given a compound like methane, then this is H, this is H, this is H, and this is H, right? So this is methane, CH4. Okay, since you already know the hybridization of methane, the hybridization of carbon in methane is actually SP3. But let's say you don't even know that information. It's actually easy. Just count the number of elements around the central atom. You can see this is 1, this is 2, this is 3, this is 4. Since it is 4, what hybridization will you add to give you 4? That will be SP3, because 1s 3p, that's 4. That will be SP3. So that's how we know that this compound here, the carbon, is actually SP3, because there's SP, there's SP3, SP2, there's SP3, there's SP3D, there's SP3D2. You understand? So in all these hybridization, which one has just 4 elements? It is SP3, because 1, 2, 3, 4. So let's say you are given a compound like BF3, and they ask you what is the hybridization of this compound. Just draw it out. This thing has 3 elements attached to it. That's F, right? What is the hybridization? Just count 1, 2, 3. That's 3 elements. 3 elements attached to it. So we're looking for the hybridization that if you add together, we just get 3. That will be SP2, because 1s 2p, 1s 2p, that's 3. 1, 2, 3, that's 3. That's how we know that the hybridization of BF3 is just SP2. So you don't need to cram it. So let's see what if diced. Understand? So on and so forth. If they give you a compound and they ask you for the hybridization, just count the elements attached to the central atom and the number it gives you. Just look for the hybridization that has that number. You understand? The hybridization that has that total number. You understand? So that's the fastest way to look for hybridization of a particular atom in a compound. So thank you for watching this video. If you enjoyed this video and if you watch to the end, make sure you like this video and subscribe for more videos like this. I'll see you in my next class. Thank you.